All right, so let's continue with some unit conversions on that same page that says additional unit conversion problems, or additional conversion problems, actually. The last one we did was number 9, so that would bring us to number 10. Okay, number 10 is 25 cubic centimeters to milliliters. That's a pretty easy one because you may have recalled me mentioning when we were talking at first about the metric system that one of the ways they really thought about the relationships between things when they set up the metric system. And they set it up deliberately so that 1 cubic centimeter was the same as 1 milliliter. And so if you got 25 cubic centimeters, that's 25 milliliters. Same thing. If you want to be formal about it mathematically, you could say 25 centimeters, or cubic centimeters would be what you're starting off with. Your conversion factor would be the fact that there's 1 milliliter for every 1 cubic centimeter. So that's your equivalent statement. You can turn that into a conversion factor by making it a ratio. Obviously, cubic centimeters should go on the bottom, and milliliters should go on top. Cubic centimeters will cancel out, and when you multiply the numbers out, what do you know? It's 25. And so this is sort of the formal, official way to do it. But you know, knowing that they're the same, you could really just say they're the same, so it's the same number. I've added a few more to help with conversions. We could try let's see. So I'm going beyond what's actually printed on the sheet here and adding a few more just for fun. So I'm going to take, say, 4,500 square feet, the size of a pretty good sized house, and convert that to square meters. So, you know, hypothetically, suppose you got a 45 square foot house and you want to buy some really groovy shag carpet for it. But the best deal on carpet is at a Canadian carpet store, and they only sell in square meters. So you got to find out how many square meters you need. So first of all, we need to find a relationship between possibly square feet and square meters directly if we can. Let's see here. We've got on the conversion factor sheet, we've got length, mass, volume, energy, speed, force, and pressure. No, nothing for area. Length units to the second power are units of area. So what we're going to have to do in this case is use the one-dimensional conversion factor and square it. And we've really got no choice in this case. Hopefully we can at least find a relationship between feet and meters. So let's see, under length, feet, there we go. 1 meter is 3.281 feet. So we can at least use that. So if we start out with 4,500 square feet, and notice I put a decimal point at the end, so that's 4 significant figures. And we have their conversion factor between feet and meters. We're going to want feet on the bottom. And we're going to want meters on top. But feet does not cancel with square feet, and we want square meters for the answer, and this is just meters. So you're going to have to square the units, but you're also going to have to square the numbers. And the easiest way to convey that is just to put the exponent, or power 2 outside the parentheses. And now that 2 applies to everything inside the parentheses. And the only catch is you have to remember that it applies to the number also. So you have to remember to square that number when you divide through. So now square feet will cancel with square feet. And this unit is actually square meters. And our number is going to be 4,500 divided by parentheses. Whoops, let's see if you can see it here. 4,500 divided by parentheses 3.281 raised to the second power, those parentheses, and then we get this. 418.02288. Okay, so we're allowed 4 significant figures because this 4,500 with a decimal point has 4 significant figures. 3.281 is also 4 significant figures. So that's it, 4. So that would be 4, 1, 8, and 0, but everything else has to go. The first number we're dropping is a 2, which means that it has no effect on the previous digits, so it's 418.0 square meters, 418 square meters. Okay? So there we go. Tungsten, as it turns out, is the most dense of all of the chemical elements. It has a mass, or has a density of 22 grams per cubic centimeter. That probably doesn't sound like a lot, but actually this is very, very heavy. It's about twice the density of lead. And the only place that we ever really encounter tungsten in everyday life would be in the filaments of the old Edison-style incandescent light bulbs. And they don't seem very heavy, so you might not notice how dense tungsten is. But it's not very heavy because the tungsten is an extremely fine filament inside those bulbs. If you've ever looked at it, it looks like it's fairly thick, but if you look at it with a magnifying glass, you'll see that it's actually a coil within a coil. So it's a very, very, very fine wire that's sort of coiled around and then coiled around again to give it a lot of surface area. But actually there's very little tungsten in a light bulb. So we're wondering if how many, basically, what would the density be if we put it in terms of things, masses and volumes that we're more familiar with? Like how many pounds would there be for every square foot of tungsten? So if you had a square foot, a standard piece of paper is about 11 inches long. So, think of a box that's a little longer than that on each side of tungsten. How much would it weigh? That's essentially what we're finding here. 22 grams per cubic centimeter doesn't mean much to most Americans and probably not to most Canadians either. But pounds per cubic foot might actually mean something. So let's see how that turns out. We've got a compound unit here. We want grams on the top, and we want to change those to pounds. And on the bottom, we've got cubic centimeters, and we want to change those to cubic feet. This is going to be a challenging conversion because I don't believe there are any, no, there are no conversion factors on the conversion factor sheet for density. So we're going to have to convert the top unit and the bottom unit separately. So for grams, let's see, we want grams, we want to go to pounds. So we can look at the conversion factors and see for mass, if we can get, oh yeah, first one, 1 pound is 453.6 grams. So we can do that in one step. So that works. Let's see. cubic centimeters. I'm going to write centimeters just for now because I don't know if there's going to be one between cubic centimeters and cubic feet. That's a volume, remember. Length units to the third power would be a volume. Cubic centimeters, cubic feet, nope. So we might just have to go from centimeters to feet. And see it. Let's see if there's a centimeter. Yeah, there we go. We can do that in one step. We're just going to have to cube the conversion factor. So 1 foot is 30.5 centimeters. All right, so let's start. 22 grams. Since we are converting the top and bottom units separately, this is a case where you definitely should write 22 grams / centimeters cubed as 22 grams over centimeters cubed, because you really want to be aware without any doubt as to which unit is in the numerator and which one is in the denominator. So it's 22 grams for every 1 cubic centimeter. That'll be the units that we start out with. Remember, for the time being, we're going to leave the cubic centimeters as it is, and we're going to focus on converting the top unit, grams to pounds. With the conversion factor we found in the table, we can actually do that in one step. We want grams on the bottom, 453.6 grams for every 1 pound. Pounds should go on top, because that's where we want it to be in the answer. Grams will cancel, and we now have pounds per cubic centimeter. That would be kind of weird since it's a mixture of English and metric units, but you could stop and write it down if you wanted to. But there's no reason that we can't keep right on going. We have successfully got the units that we want on top. So now we're going to come back and convert the units on the bottom in the next step. It's cubic centimeters, and we've got a relationship between centimeters and feet. So you want centimeters on top and feet on the bottom, because you want feet on the bottom here. Only it's cubic centimeters, not just centimeters, and it's cubic feet we want on the bottom, not just feet. So you're going to have to cube this entire conversion factor. And again, I'm going to circle it for emphasis. And now cubic centimeters will cancel with cubic centimeters, and we will end up with cubic feet on the bottom. It's just that when you multiply through, you're going to have to raise 30.5 to the third power. So don't forget to do that. So if we take 22 divided by 453.6, and then times 30.5 raised to the third power, we get 1,376.09, blah, blah, blah. Let's see, for the significant figures, we've got 2 here. Here, the 1 is an exact number. The 453.6 would be 4. 30.5 would be 3. The 1 is an exact number. So 2 has it. 2 is the number of significant figures we're allowed to have here. That would be the first 2 digits, and everything after that has to go. Note that the first number we're dropping is a 7, which is greater than 5, so that means the digit before that has to go up by 1. Okay, 14, and you're dropping 2 digits before the decimal point, so they have to be replaced by zeros to maintain the magnitude of the number. No decimal point, though, because that would make this 4 significant figures. So that would be your answer. The density of tungsten is 22 grams per cubic centimeter, which corresponds to 1,400 pounds per cubic foot. So if you had a box of tungsten that was 1 foot on each side, it would weigh 1,400 pounds. That is a lot of weight. I mean, that is, if you think about it, that's probably about, say, half a Chevy Cruze, or maybe about the mass of one of the old school Volkswagen Beetles, you know, back when the engines were in the back. They weighed about that much. And that much mass is crammed into 1 cubic foot. So that is an extremely dense metal. Okay, we can also try something like converting miles per hour to meters per second. It's quite likely that there will be a conversion factor in the table that will allow us to do this in one step. So let's have a look. Miles is a distance, hours is time. When you have distance over time, that's a speed. So if we look under speed, for miles per hour to meters per second, there's one, the first line. It says 1 kilometer per hour equals 0.2778 meters per second, which is also equal to 0.6214 miles per hour. So you can actually use those last two terms as your conversion factor. In most conversion factors, we have it so that one of the units is 1 and the other is some number, but it doesn't have to be that way. As long as you know two measurements in those units that are equivalent to each other, you can use those numbers. And neither one of them really has to be 1. Okay, so we could use that. 186,000 miles per hour. And that would be equivalent to being in the numerator. Times, and now we want miles per hour on the bottom of the conversion factor. And we want meters per second on the top. Miles per hour now will cancel, and we end up with meters per second as the answer. And we would do this mathematically as 186,000 times 0.2778 divided by 0.6214. And we get 83,152.23688 meters per second. Now, about the significant figures. This obviously is way too many, so we're going to need to cut down a little bit. Let's see, 186,000, and there was no decimal point to begin with, so that's 3 significant figures. The 1 is just to show that this was in the numerator, so that's an integer, so it's an exact number, infinite significant figures. 0.2778 and 0.6214 each have 4. So 3 it is. That would mean the 8, the 3, and the 1 can stay, but everything else has to go. First digit you're dropping is a 5, so the number before it has to go up by 1. And also you're dropping 2 digits before the decimal point, so you have to replace those with zeros so as to have the same relative magnitude, and that would be meters per second. 83,200 meters per second would be equivalent to 186,000 miles per hour. Okay? Okay. You can convert the unit on the bottom and the unit on the top separately. If you're going to do that, though, if you're going to convert the top and bottom units separately, that would be a time when you would definitely want to write the number as 186,000 miles over 1 hour. Okay, so just so it is clear, what's on the top and what's on the bottom. It makes it easier to make sure that things cancel out and that the units work out right as you're working out the problem. Now, what we need to do is go from miles to meters, and we need to go from hours to seconds. 1 hour is 3,600 seconds. And we know that because there's 60 seconds in a minute and 60 minutes in an hour. So to get from seconds to hours, you just have to take 60 times 60, which is 3,600. You could do it one step at a time too, which I think I showed in a previous example. But we might as well get used to using this because we'll see it fairly often. Okay, from miles to meters, let's see if there's a conversion back here in the back of the book, or yeah, the back of the math section. Well, there's miles to kilometers. So using what the conversion table gives us, there's 1 mile for every 1.609 kilometers. And once we're in kilometers, we can easily change to meters because that's just a matter of the metric prefixes. 1 kilometer is 1,000 meters. So we can try this now. We're going to might as well convert the unit on top first and then come back for the unit on the bottom. So first we want to go from miles to kilometers. That means we want miles on the bottom of the conversion factor, so it'll cancel out with miles on the top here. So it's 1.609 kilometers for every mile. Miles will cancel, and you'd have kilometers per hour if you wanted to write down the answer now. But there's no reason to. We might as well go on to meters. Now that we've got kilometers, we can go to meters because 1 kilometer is 1,000 meters. Again, you want kilometer. You want the unit that's in the top in the previous step to be on the bottom in this step, so they'll cancel out. And you want the new unit on top. So kilometers cancel out. And if you work this out now, you would have meters per hour as your unit. Now we've got the unit we want in the numerator. That's why I'm circling it, just to remind us that we're done with that. And we can come back and convert the unit on the bottom. When you convert units on the bottom, you do it just like converting units on the top. The only catch is you have to remember that the unit you're converting is on the bottom, which means that in any conversion factors, that unit needs to go on top so that they'll cancel. So we have 1 hour is 3,600 seconds. And so 1 hour goes on top so that it cancels with this hour over here. And 3,600 seconds remains on the bottom. And that's where we want it. We want it meters per second. When you multiply this out, it's 186,000 times 1.609 times 1,000 divided by 3,600. And that gives us 83,131.6 repeating. All right, that's obviously too many significant figures. We have 3 significant figures here. 1.609 is 4. These numbers are exact. That's a definition within the metric system, so that's infinite. 1 hour per 3,600 seconds, is also infinite. So 3 is the limit on significant figures, just like it was up above. We have 831, and everything else has to go. The first number we're dropping is a 3, so it has no effect on the numbers before it. And you're dropping 2 numbers before the decimal point, so that has to, so they become zeros to maintain the magnitude. And for the first time, we didn't get exactly the same number that we got doing it all in one step. That's because these conversion factors were rounded off a bit differently. So we came out with a number that didn't quite round off to 83,200. It was rounded off to 83,100 instead. But that's very close because the only difference is in the very last significant figure that we have here. And like I said, we usually consider the last significant figure to be uncertain anyway. So these numbers, for all practical purposes, within the limits of the significant figures we know, those are for all practical purposes the same. Okay, so that's some unit conversions for now. We have more that we can do, but I think I'm going to stop there. And that's a convenient place to stop according to what's in the math section. So we'll continue on later. See you then. Bye.